Hi guys, today we're going to be looking at forms of quadratic equations, and we're going to specifically focus on a form called vertex form. So what's going to happen here is we're going to be looking at a parabola, and we're going to be looking at its equation, and we're going to find important information about that parabola just by looking at the equation. No graph, no anything else. So first, let's talk about these three forms of quadratic equation. Now we're only going to focus on vertex form here, but there are three different types: vertex form, intercept form, and standard form. We're going to talk about all three, but right now our focus is just going to be on vertex form. So vertex form kind of looks like this, and remember what we're wanting to do is take this equation and find key parts of the quadratic from it. So here are some of our key parts that we can find. In fact, these four are the four most important that we're going to talk about from a quadratic function. So here you can see the graph of a quadratic. Remember, it has this characteristic U shape that we call a parabola. And there are four features that we need to find from our equations. The first is called the vertex, and so that would be this point right here. And I'll draw a line to that. So the vertex, and we always give the vertex as a set of ordered pairs. So in this case, the vertex is at -1, -4. And we also have, while we're talking about it, the axis of symmetry, which is an imaginary line that passes straight up and down through the vertex. And we describe it by giving its equation. And it's always x equals, and then whatever the x value of all the points on that line are, which in this case happen to be the same as the x coordinate of the vertex. So -1, just like up here. Now remember that axis of symmetry is the line that cuts the parabola perfectly in half so that each side is a mirror image of the other side. We also have our y-intercept. That's where this thing crosses the y-axis. So right there would be our y-intercept. And the y-intercept can be written two ways. We can either just give the y value, or you don't have to write both of these. You can just pick whichever one you like better. Or we can give its coordinates, which in this case would be 0, -3. And then finally we have the roots. And the roots are those places where the graph of the function crosses the x-axis. I have two ways of writing those. I can say x equals, and then whatever my roots are, so x equals -3 and x equals 1. Or I can write them as ordered pairs, -3, 0, and 1, 0. So either way, you don't have to write both, but whichever one floats your boat. So these are all the key parts of a quadratic. And what we're going to do now is we're going to be looking at an equation in vertex form and seeing which of these four we can find very quickly and easily. So vertex form looks like this right here. You can see a version of it written below the graph, and this graph and this equation do match. So this equation goes with this graph. And vertex form allows us to look at this equation and very quickly find the vertex and the axis of symmetry. So in order to do this, we have to look at our vertex form in terms of all its different parts. So it's going to look like y equals a times x minus h squared plus k, where a, h, and k are all just numbers. Like there are going to be numbers that replace those letters. Y and x stay the same. That squared term stays the same. But once I find these numbers that are in here, I can very easily find the vertex. It's just hk. And I can very easily find the axis of symmetry. It's just x equals h will be the equation for that axis of symmetry. And so knowing this, let's take a look at a couple and see if we can just find them. So here we go. Find the vertex, an equation of the axis of symmetry from the quadratic equation below. This thing is in vertex form. And so what I'm going to do is I'm going to write out our generic version of vertex form. Don't forget the square there. That's easy done. And let's just find now what are A, H, and K. So before I do anything else, let's take a look at this equation over here and find A, H, and K so that I know what I'm dealing with. Well, A is going to be the number out in front of the parentheses. So in this case, A equals 6. H is going to be the opposite of whatever is paired with the x inside the parentheses. So the opposite of -2 would be +2. So H is 2, and K is whatever number is on the outside. So just 5. And when I say outside, I mean outside added or subtracted to the end. So now I have A, H, and K are my parameters for this equation. And to find my vertex, all I got to know is that it's just H, comma, K. So in this case, my vertex is just going to be 2, 5. Easy as that. No calculations, no complicated anything. I can literally just read it out of the equations. The opposite of that for x and that for y. My axis of symmetry is just x equals h, which in this case is 2. So there we go. There are my two answers to those problems, read directly out of the equation. Again, no calculation. Just look at it and tell me. All right, let's do another one. So I'm going to do the same thing as before. Let's find A, H, and K very quickly. A is the number out in front of the parentheses, so in this case it's -3. H is going to be the opposite of the number in parentheses with the x, so in this case -6. This was a +6, so H is a -6. And then K is the number on the outside. Well, it's -2, so K in this case would be -2. Now that I know that, I know my vertex is just HK. So H is -6, K is -2. There's my vertex. Easy as that. For the axis of symmetry, it's just x equals h. Well, h is -6, so x equals -6. And there you go. I found the vertex and I found the axis of symmetry from vertex form. It is as easy as that. All right, so to recap, quadratic functions, every single one of them is going to have vertex, axis of symmetry, y-intercept. Sometimes they'll have roots. And we have three different ways of writing these equations. Vertex form allows us to find the vertex and the axis of symmetry with great ease. All we have to do is find the three parameters of the equation, A, H, and K. And once we know that, our vertex is just going to be HK, and our axis of symmetry is going to be along the equation, x equals h. So what we're going to do now is we're going to look at a bunch of these equations, make sure we can find the vertex and the axis of symmetry, and then we'll cycle back around to this and use that information to graph the function.